A very good afternoon to all of you, dear learners, and all my colleagues over here. Today, to start with our course number 4, that is in ecological economics, we have with us Dr. Muhammad Khalid. The reason why I am very interested to introduce him is that he is our alumni, right? Uh, he must be second batch of PGDH's ODL, right? Ahmad, if I'm not wrong, you must be second batch, right?
Yeah,
And
yeah, I'm the second batch.
his education, looking in, then coming to his education, his basic education is from Aligarh Muslim University, followed by that's in economics, and followed by PhD from IIT Delhi. And after completion of his PhD, he worked as a postdoctoral fellow of ISA Bangalore. In the meantime, after he within a span of 2 3 months, he got a letter from that UNU Japan under JSPS-UNU fellowship as a postdoctoral fellow. His expertise is on, we can say, development economics. So I'm sure being a student, alumni of sustainability science, postgraduate diploma in sustainability science, he will take us towards the direction of interdisciplinary understanding of ecology, economy, interaction, and energy relationship. Once again, I welcome you, Dr. Khalid, and over to you to start the session. Okay, Khalid. Okay.
Thank you, everyone. Welcome, everyone. Good afternoon. Thank you for a nice intro, Professor Kuman. So today I'm present on the MSD 014 Ecological Economics, covering for this counseling session, which I have titled Ecology, Economy, and Relationship. So I would like to start with this by Paul Watson. Paul Watson is a Canadian environmentalist and he's very active in America and Canada. So he says, I quote, people are beginning to realize that we need the law of ecology, the law of finite resource, and if we don't, we are going to. So I think my this presentation very well summarizes this quote. So now we would like to move forward. So for today's session, I have outlined as follows. I'll have a brief background about how the ecological thought developed and its association with economics. Then I'll discuss few key terms in it, followed by the evolution of economic thought, relationship with ecology, how it was shaped, and I will present a simple framework given by 2016, discussing the economy environmental linkage. Then discuss uh, trade-offs between economic growth and environment, in which particularly I will focus on the Simon Kuznets curve, that is called the EKC curve. Then I will also talk about how energy is associated and what its role and how it impacts economics. In fact, how it derives from economics, how economists have benefited from energy principles, particularly talking about law of and its application in economics and association with environment. I'll talk about the characterization of resources, few key concepts I will talk: suitability, rivalry, stock resource. Then, based on that background, I will show a of abiotic and biotic resources and characterize them. I have also read some readings and a video, and that will be followed by a Q&A session. So let's move forward. So, environmental and resource economics, particularly was a sub-discipline of economics, we can say after Second World War. Though, say the development and thought provocation started in the 17th and 18th century, economists, but classical economists, neoclassical economists have shown. And if we look at any civilization, we'll find that mostly the civilizations have been built in areas where there were fertile lands, river basins. And the reason was availability of resources, water, land, which was fertile. They can. So as economies grew over the period of time, population grew, consumption of resources started to increase, and it increased at a faster pace that could not be replenished. So there was issues of scarcity and exhaustion, and economists were concerned about these issues. Economists thought that it might lead to economic and social collapse. During the industrialized period and during the 19th century, during with some development and industrialization, environmental was pollution was also. So we can say that scarcity, natural resources, environment pollutions, these were some of the key topics which stirred the ecological and environmental debate, and this was a became mainstream. And a lot of work have been done by economists, which has shaped these particularly the works of classical economists like Adam Smith, Thomas Malthus, John Stuart Mill, and there are also some of the new classical economists like Jivan Stevens, Arthur Pigou, and we'll discuss this in subsequent slides. Here are some of their key theories. There was a debate, particularly two groups, as I mentioned. One was the market economy. So they wanted the markets to act freely because they thought that it was optimal level of environmental protection and resource use. Then there were others, the free market, who advocated use of incentives to reduce environmental externality instead of command and control because they thought that this will lead to flexibility. So one of the examples is the Arthur Pigou, the Pigouian tax. I will also talk about this in one of this. So the mainstream economic theory has tended to assume that economic systems of environmental distance and that we can ignore. However, and most of the economists assume environmental pollution as an externality. What is an externality? Just in the next slide, I'll talk while discussing the key terms. So in this slide, I have put terms which will help us and make us the background. So ecological economics is the branch of economic theory that assumes link between the health of the ecosystem and the human beings. And when we are talking about environmental economics, the particularly the focus is on efficient allocation of environmental resources. And when I say efficient allocation of environmental resources, I also mean that they are socially optimal. So we not only are efficiently allocating the resources, but also taking care of social. For example, if you look at the forest resource and the tribal people living there, so that is a main source wood. It provides a lot of ecosystem service to these tribal people. So whether rights are met or also not, environmental economics also concerns that. Now, as I mentioned in the earlier slide, so externality, externality, we can assume it as something which exists when production choice of one person or firm enters the utility or production of another entity without that entity's permission or compensation. So the externality can be two types. It can be positive, it can be negative. Let's take an example. Suppose I'm a common person. I'm walking in a city. There are cars going. There are factories. So for me as an individual, I'm strolling in the morning, taking a morning. The cars are also going, industries polluting. So that pollution externality, it can be called as negative externality. Because I as a strolling on the road doesn't want that. Neither I'm compensated, but it is being emitted. So it can be a negative externality. Now talking about positive externality, take an
Ahmad,
example.
Ahmad,
Yeah,
Ahmad,
yeah.
your voice is breaking. थोड़ा सा
Okay, okay.
माइक्रोफोन को आपके नजदीक में ले लो.
Sure, sure, sure. So taking an example of externality, suppose I live in a colony. Neighbor has a very beautiful lawn, which my neighbor maintains regularly, gives water, flower. There are a lot of flowers. So when I look at it, I'm pleased with that. It gives me happiness and joy. So for me, it's a positive externality because my neighbor has not asked me any compensation or something that you cannot watch my garden, beautiful garden. It's free for me. So it's like a positive. It is in my utility. It is giving me happiness, but I have not paid for it. Now, as I was talking in the very slide, that there are several economists, and they have given theories which has actually the development of ecological economics. So one of the most there are so many classical economists and neoclassical. I have presented few of them. Talking about the classical ones first. So one of the very famous economists is Adam Smith. Any student of economics will acknowledge. So he gave some of the theories. I have mentioned three of them. There are many theories given by all of them. So laissez-faire, it's a very famous theory given by him. Laissez-faire, French term, which means minimum hindrance. So minimal government intervention. So according to Adam Smith, market will fine if we leave it to it. Like there is no government interventions, and just there were so many criticism of it, but this is what this theory mean. He also gave theory of value. So where he talked about value, two types of value. One was value in use and value in exchange. The focus was on total utility, and one of the different. There's also a key difference between the classical economists and the new classical economists. The classical ones, like Adam Smith, they talk about total utility, and if you go to new class, they will talk about marginal utility. And next, theory on distribution of income, where he categorized people into classes. One was capitalist group, laborers, and landlords. Second, I'll talk about David Ricardo, who has given several theories. I put up three of them, and the most famous theory given by him is theory of comparative advantage, theory of rent, which discusses issue of ownership and productive activity. So, for example, the main premise under theory of rent was that we can take a farmer who's working on landlord's, and he gives him tax, or he gives him rent, say monthly rent or annual rent. So he was saying that the landlord is just having the ownership, but the productive activity is all done by the farm or the laborer. So in this way, he is becoming richer and richer. So he questioned that with the theory of rent. And now talking about theory of advantage, which talks about issues such as opportunity cost and mutual benefit. Here, David Ricardo said that suppose there are two countries. country B who produce product. So, according to theory of comparative advantage, he David Ricardo, any country or firm cannot have at who should the opportunity cost of production be minimal for everything they produce. They will specialize in particular or a few. So they should produce the goods or services in which they have the least, and as they specialize, the costs will increase, and there is chance trade, trade agreement between them, and so by doing that, both will benefit. This is what competitive advantage. For example, take Taiwan. Taiwan is a country manufacturers the chips used in computers, and it is one of the main exporters globally. Even China today depends on Taiwan. 70% of the world depends on Taiwan for that chips, silicon chips. It is a major. So Taiwan has a comparative advantage in producing those silicon. China imports it, then it uses it. So here a trade agreement with and Taiwan is benefiting both of them because Taiwan specializes in production. Now talking about labor theory of value. So by value, he said that cost should not be based on compensation paid for the labor, but on the total cost. For example, if I have employed sub laborers and I want them to make me a chair and one table, and it takes two to make one table, and one chair takes 1 hour of labor. So, by labor theory of value, David Ricardo said that one table is equivalent to two tables. So, the focus is on the total, not on the compensation that was paid. Now, talking about Thomas Malthus, population theory, and where he said that if population left unchecked, can be an exponential growth which will exceed high levels, and there will not be resources for individuals. And he also said that naturally the population will correct by means of if there are wars, famine, diseases. But this was criticized by many economists, and they said that here Thomas Malthus have not taken account aspects of technology, and they have criticized him for that. Then one of I'm talking about John Stuart Mill. He gave the principles of political economy, where he talked about population limits and slowed economic growth are beneficial to environment and increase public growth. And this is one of the premises many economists get: if we are able to control the population, and that is good for the public good, beneficial for the environment as well. Theory of utilitarianism in 1863. He says, I quote, actions are right in proportions as they tend to promote happiness, as long as they tend to produce reverse of happiness. So, particularly, he was talking about what gives you happiness promotes happiness. Now, last two which I have mentioned are both neoclassical economists, Stanley Jevons, and he very famous. His theory is Jevons paradox, which he gave in 1865. Theory talks about technological progress and improvement in energy efficiency of resources. So let me tell you the paradox by giving example. It is British example, particularly where during industrialization, coal was used as a resource, as a fuel. So there were a lot of talk about technological progress, and people thought that if you'll increase the efficiency, so shows that will decrease the consumption of the resource. What happened in Britain that with technological process, energy efficiency improved, but at the same time, the demand, the rate of consumption, also because of increased demand. So it was contrary to what the economists thought. Increasing the energy efficiency will save the resource. In fact, the demand further increased. Now, talking about Arthur Pigou, so Pigou is also a new classical economist. He talked about externalities, which I talked earlier also. If there is this externalities, so there is a role for government to. He talked about taxes, which is also very famously called the tax, and he says that a tax will discourage. So, for example, we do not have any government intervention and firms keep on polluting, time is not away that the environment has a capacity of itself. A lot of environmental pressure, the world will not be like a living place. So, government, there is a tax which he suggested, and this tax will be paid by the firms. There's this tax he talked about who are polluting, and he also talked about subsidies and who do not pollute or who pollute less and who are moving toward technologies which are energy efficient or which pollution. Now with this, I think a little we are shifting on framework how economy and are linked. So Ahuja has given a simple framework. So you can see on the right side circles. There is a two circles. One is a small inner circle and outer. The outer circle is what constitutes the environment, and in the inner circle we have farms and households. So the environment economic activity, and in the same time the environment also supports economic activity hub. So we can see that the inner circle, there are arrows pointing towards it like resources, amenities, life support. So the firms are producing goods and services, which are man-made capital, labor, natural resources. These are being produced because there is a consumption by household, there is a demand from households. They are producing. So, and for producing, they are taking resource, amenities, life support, and at the same time, when they are produced those goods and services, there is also an impact on the biodiversity. For example, producing waste, there's producing air and water pollution, so impacting the environment. And also, the environment plays several. For example, different parts can have different roles. Let's say oceans. The oceans provide water. The oceans are also an ecosystem for marine aquatic life. The, the factories, the companies also discharge in it. The oceans as aquifers. The oceans also act as purifiers. They absorb carbon dioxide. So we can say that economy and environment are interlinked. Both depend on each other, and that cycle should not break. Limits. It's not like we can keep on dumping in the ocean. We cannot go on in the atmosphere. Uh, Talking about the trade-off between economic growth and environment. So, time until today, the relationship between economic growth and environment is controversial, debatable. It involves trade offs, several economists have explored the relationship between the level of economic development and inequality. So on my right side, there's a curve called I'm going to talk about the EKC hypothesis, one of the as an example of this trade-off. And you can see there's a red color U-shaped curve. One of the things that you take care is that on my x-axis, the stage of economic development, and the indicator that has been used is growth in income per my y-axis. It's environmental degradation or pollution. And sometimes if you see in literature, you will also find the emission axis. There is one CO2 emission per capita or some pollutant per. So, but the motive is that it represents the y-axis represents environmental degradation. So here in the curve, you also see two and that separate three columns. One is shown as pre-industrial economies, the middle part industrial economies. Then there is the last part which shows industrial or service economies. So the basic premise of the EKC curves is that we see that as the growth in income per capita increasing, the first column you see the pre-industrial economies, or you can say that poor economies, which are developing, early developing economies which are developing. So for development, they will require resources, lot of resources, and they also do not have good technologies because they do not have capital, do not have that money, so they cannot afford clean technologies. So for development and growth, they will consume resources at a fast rate. So that's why there's a lot of stress. First column, we see there's a rise in degradation as income is growing. So then we see in the middle part, so the which is depicted levels of it flattens. So at a particular rate where economy has grown, so the per capita incomes keep growing. And if we say that it matches with the industrial economies, so we say that it is a, and then it is going down. One of the reason is that as income is in, so there is also a rise for environmental quality, demand for environmental. Now the economies can afford to go for good technologies, energy efficient technologies, which putting up less pressure. So after that, investment in technologies and actions that reduce pressure at the same time growing, income per capita is increasing. So after that, the industries all see that industrial economies moving to service economies. So India's IT sector is also a big contribution. It is a IT sector and it's a good contribution. So after level of development, the manufacturing and industrial percentage of countries they shift towards service economy. Move towards service economies, the pollution is less, and one of the reasons that the service sector is less energy intensive and less polluting. That see that though income per capita, growth in income per capita is increasing, but there is a fall in. However, this is not a standard AKC curve. AKC curves can different shapes like S, like N, and it has been with the help of different pollutants and environmental impacts. It can be how much waste generated per unit or how much emission per capita has been emitted. So the curve can differ and the curve can for different economies. economies, different regions. So this is just a basic, the environmental Kuznets curve. And one of the premises say that, so we need to control population, break poverty, poor country, and developing countries. And if we do that, then we're going to do good to the environment. Now, in this slide, which I've titled Energy, Economics, and Environment, trying to present that how economics benefit from energy principles or theories of, which is also associated and relevant for the environment. So we all know when we hear energy, matter and energy, we think of the physical sciences. So physical sciences deals with energy. On the other hand, the economics deals with production and exchange of goods and services. The goods and services, for producing goods and services, there's no sector, no industry which is producing goods and services do not consume resources or energy for the production of goods and services. So in a way, you can say laws and concepts which are applicable to physical sciences may be applicable to economics also. So below, I talk about the laws of economics and how it can be utilized and how it has been utilized by economics. So the first law of conservation of energy, which says that energy cannot be created. So here we talk about use of resource, generation, treatment of waste. So there's a very famous economist whose work, Jacques Regain, who has used a Cobb-Douglas function. Cobb-Douglas function, which talk about the quantity of output, which is a function of, say, capital, labor, and here in this function, here is also a function of natural resource, which Jacques Regain talks about. And then he calculates the coefficient for the natural resource, and then he questions and relates it with law of conservation, thermodynamics. Similarly, Pierce and Turner, they have talked about biggest generation and amount of resource use. So in one of their equations, which is very math, very simply I'm putting it, he says that the total amount of resource use is equal to all the waste generated throughout the process. And he again relates it with how the law of conservation of energy. And the second law, which deals with law of increase in entropy and puts constraints, economic process that reduce available work. We can understand the example that suppose there's a country or economy or industry that raises productivity, disruption of economic energy supply, produce benefits for other economy. If it's raising its productivity and has disruption of economic energy supply, so it is benefit other economies because of the improved techniques, maybe because of new product methods, cheaper products, etc. Lastly, talking third law of thermodynamics, entropy of the system absolute zero is constant. There was an economist called Walras. So he gave the very famous diamond equilibrium, where he assumed price and quantity are in equilibrium, inadequate, and there is adequate auction, information is sufficient and perfect. But we all know that in real world, misalignment in the form of price, amount, and what he calls as entropy, and thus the entropy will not value, and he relates it with the third law. Now, coming down to the characterization of resources, so there are some terminologies which I have presented, and first slide, there's a stock flow resource and for service resource. So a stock flow resource, we can understand something like raw materials provided by nature quickly transformed into economic products. So, for example, we use timber, or say, I've written tree. Say, so tree is used to make wood house, for example, and fossil fuel, fossil energy, converted to other forms of energy or waste. For example, if the in industries, coal power plants, burn as a fuel, and you have steam, which runs the turbine, and steam is released, and other gases are released into the atmosphere. These are other forms of energy. And the fund service resource. So the key difference between a stock flow resource and them is that configuration of this stock resource, and they don't become the part of output use, and there is always some wear and tear involved in that. So a good example would be a forest ecosystem, which is comprising of different plants, animals, soil, mineral resources. It also provides large variety of ecosystem service. But suppose the forest is cut, everything remains the same, but no longer we are able to generate the same ecosystem service as before. Now, talking about rival resource, so we can simply understand a resource to be rival. We say it is a rival resource when used by one person leaves less or quality for another person. For example, food, fiber, fossil fuel, and a non-rival resource is whose use does not leave less for other to use. It's not scarce. There's no competition. For example, street light is a public street light, and everybody. If I am using it, I cannot stop you from taking benefit. Similarly, something scenic is there. I cannot stop you. Naturally free. It's available for all. Then there's also another concept called excludable principle called excludability. It said that a resource is excludable when one person or group can use a resource while preventing others from doing so. So it involves property rights. So a good example of excludable resource would be, say, cinema tickets. We watching movies. So if I buy a ticket, so of course the cinema has a limited capacity. So I have taken up one seat. So the remaining hall is short of one seat. Similarly, a parking space. There's a capacity of 500 vehicles. So there are already 100 standing. So now those 100 cannot be used, and others can only use the remaining four. Excludable resources. When resources have no property rights and can be accessed openly by, for example, fishes in the ocean, anybody can go. However, now countries have defined shorelines and that you cannot go to another country's a restricted area. So if we do not talk about those aspects, then we can say that fishes in the oceans are non-exclusive. And when I say that those restrictions, then definitely I'm talking about the excludability. And here comes the role of policy institutions. Now, based on this, Here are some examples which have been classified in terms of entropy, service resource, excludability, or rivalness. So, fossil fuel is very clearly excluded. If somebody consumes it, then less of it is rival. Yes, it is also rival. Water, if I talk about water, so it's contextual in the sense that the debate is, suppose there is a reservoir open to public, say in a city, and everybody is consuming. If we do not put any restrictions, though, people will start consuming it. So it will get depleted and get exhausted. So that's why then there can be some restrictions that you cannot use it. You cannot use it at a level. There is some charge. So that's why how it has been categorized, where it is, what exists. It can be contextual. That's why it can be excludable, non-excludable, rival, non-rival. Similarly, solar energy, we cannot exclude it. And here, many people will be confused that ultimate source of low entropy. So we have to distinguish between entropy and thermal energy. Because then the moment I will say sun, people will think that sun is very high temperature. The way entropy is defined, entropy, you can say the randomness in a system. Assume an example. There is a cup of tea in the room that is hot. So if I leave it for some time, the tea will become cooler and it will equal to the temperature. But it will never happen that the temperature of the cup will increase. But the temperature has decreased of the tea has become cooler, but the entropy in the room has increased. So I said that the randomness you can randomness has increased. Similarly, the entropy equation has defined thermal upon temperature. So the temperature of the sun is almost 55 degrees Celsius. So it's in the denominator. So that's why entropy is low, thermal energy is very high, and always you need a sink, a cooler place where thermal energy transfers hot to cooler. It's a low entropy energy. Don't confuse by thermal energy. How other services have been defined. I hope now classify the resources in terms of entropy, stock and service excluded rival, among others. So I think this is covered in this counseling session. And to summarize, we can say that leading economists, particularly the classical economists, have laid down strong ecology, economy interaction. Environment and economy interaction and linkages can be with frameworks and models. There always exists a trade-off. It's a tough debate, and the laws and concepts, like the sciences like laws of thermodynamics, have wide applications to understand functioning of an economy or industry, and have implications for the environment. And abiotic and biotic can be categorized and categorized based on their inherent characteristics. That's all from my side. And these are the references we have used in this counseling session, this talk. And these are some of the I have suggested, which people can look. And I think that's all from my side. And now I'm open to questions and answers. Hello.